Okay, so I had to get pumped up for this lesson because this lesson, it's not hard, but it has imaginary numbers in it. And even though I'm a math teacher, I should be great at everything math related. Imaginary numbers just mess with my head because when you're saying an imaginary number, that just doesn't make sense. It's like an oxymoron. So, the second page of these notes there's just a little bit of imaginary numbers, and please forgive me if I pause this video and then come back to it because I just don't like it. I'm just like you all. There are some things that I just don't like, and I don't like this. Hang on, my battery's about to die. I need to plug this in. I think my computer is just like over it too. Okay, so, wow, that got really bright. All right, so this first part of, and this is called using the discriminant. The discriminant is just kind of one part of the quadratic formula that will show you a lot of information. Light in the background. It's bright. So I'm going to turn off that kitchen light. I feel like it's not bright. Probably don't want to see all the notes and magnets I have anyway on my refrigerator. Well, you can still see them. Anyway, okay, so Charlie starts to solve this quadratic equation, but claims that there are no real solutions. Do you agree or disagree? So you might see, okay, we can use like the square root method and do square root of both sides, but we have -9, the square root of -9. That's like, we don't have, so like the way and this is where imaginary numbers come in, and it's just hard for me to explain this. So if you have two numbers that you're multiplying together, it's going to give you a number. -3 times -3 gives you +9. +3 times +3 gives you +9. But there aren't two of the same numbers that will give you -9. Does that make sense? So the answer to this is I agree with him. Oh, sorry, my computer's being funky. I agree. And it's not working. Everything's just over it right now. Agree. There are not two of the same numbers when squared that produce, sorry, I don't know how to simplify this, a negative number. Okay. So quadratic equations can have one, two, or no real solutions. Okay, we've talked about that where you can have like no solutions to something. You can have infinite number of solutions. You can have one solution. With quadratic functions or quadratic equations, you can have one, two, or no real solutions. Okay, the discriminant in an expression, discriminant and is an expression in the quadratic formula that will give information about the number of real solutions. So it's going to tell us right off the bat how many real solutions we have of that quadratic equation. So the discriminant is used to find the number of solutions. Also, the number of x-intercepts. So we talked about vertex form earlier, and vertex form will show us like where those x-intercepts are. So this will tell us if we have x-intercepts. Okay, so let's use this discriminant. So the discriminant, remember in the quadratic formula, that was -b plus or minus the square root of b squared minus 4ac. So when you are looking to find the discriminant, all you have to do is use that part of the formula. So you do the same thing where you have to put it in standard form so that you can then say what your A, B, and C values are. So A for this one is 1, B equals 4, and C equals 4. So if we do the discriminant and put it in that formula, so that would be 4 squared minus 4 times 1 times 4. 4 squared is 16. 16 minus 4 times 1 times 4, that would be 16 minus 16. So the discriminant is 0. Okay, I'm going to go across and do all the discriminants first. I'm going to do that part of the chart first. Same thing for number 2. Let's determine what our A values are, A, B, and C values. So A equals 1, B equals -1, C equals -30. So this would be -1 squared minus 4 times 1 times -30. If you put all that in your calculator, you get 121. Oops, I'm doing this in green. 121. Okay, next one. A is 1, B is 4, and C is 7. So we've got 4 squared, 4 squared minus 4 times 1 times 7. If you put all that in your calculator, that is -12. -12. All right. So now, number of solutions. So if you were to work these out and actually use the quadratic formula in that equation, that's going to give you your x equals 1 and x equals 2, whatever that is. So if we were to work this out, which for the sake of time, I'm not going to do that just because I'm tired. If you all want to pause me and work these out on your own, use the quadratic formula, feel free. But I am just going to write out the answers. So the solutions for this, if we were to work this out, x equals -2. The next one, -5 and 6. And then this last one, I'm actually going to do the last one with you because I want you to see how this one comes to be. This one is no real solutions. So we're going to put this fully in the quadratic formula. So we know that -12 is the inside. So our quadratic formula is negative. It starts off with -b. So that would be -4 plus or minus square root of -12 divided by 2 times 1 right there. So hopefully you all see what I'm talking about, how this kind of ties into that very first part. This x squared equals -9, square root of -9. There's not a real solution to that, to this -12. Whenever you have a negative number inside of a square root sign, that's where those imaginary numbers that I just hate come into play. So whenever you have a negative number for your discriminant, that means there are no real solutions. Okay, you can just stop right there and be like, bro, no real solutions. Done. I know this. Okay, so for this first one, we have 1 solution. We have 2 solutions. And we're going to say the last one, we're just going to keep it as no real solutions. So same thing. Just writing that a second time. Next, we're talking about, so now we've figured out what the solutions are. And that tells us how many x-intercepts we have. I'm just going to write the same thing, one x-intercept. So it's going to cross the x-axis at one place. This one's going to cross it at two places. And this isn't going to cross it at all. It's not going to cross that x-axis. All right, so let's think about what these numbers mean. So when you have 0 as your discriminant, so I'm going to kind of go out of order in this next chart. Whenever your discriminant equals 0, that means you will have, there is one solution and one x, I guess I should make this as a 1 x-intercept. All right, I'm going to go back up. When x is, or when your discriminant is a number greater than 0, there are two solutions and two x-intercepts. So again, this is that parabola. So if it's like an upside down, like a frown, where it crosses that x-axis. Again, positive, it's a positive parabola, then it's gonna, again, it could cross that x-axis 2 spots. Excuse me. If that discriminant is less than 0, so a negative number, that's where it will not have any x-intercepts. So we saw one yesterday, or no, day before. I'm doing all these videos together, so I don't remember. It could be down in like quadrant 4. It could be a negative parabola, and it's never going to cross that x-axis if it's in quadrant 4. So no solutions, no x-intercepts. There you go. That's it. All right. Here we go. All right. Here's where things get a little fuzzy for Miss Flick. All right. If the value of the discriminant is negative, so again, that number inside of the square root, that's a negative number because the discriminant is that value inside of the square root sign. If that is negative, there are no values within the real number system to represent a solution to an equation. However, imaginary numbers provide a way to represent square roots of negative numbers. Oh, I just hate this. So imaginary numbers, they are part of the complex number system. So we have our just regular old number system where we've got our integers, whole numbers, rational numbers, irrational numbers. I'm missing something. Whole, integer, real. No, it's under the real number system. Whole, integer. I'm missing one. Rational, irrational. Anyway, these are part of the complex, so a bigger umbrella. These are numbers that are negative numbers inside of a square root that are represented by that lowercase, like italic I. So if we are using Charlie's equation from the beginning where it was x equals square root of -9. So first step to kind of rewriting that is to rewrite the radical as a product involving square root of -1. So product being two numbers that we multiply together. So that would be like square root of -1 times square root of 9. So again, product of two numbers. So we're just kind of like breaking it apart. So when we simplified equation or expressions, we simplified that radical down. So if it was like, let me try to get a good one, square root of 24, we could simplify that down as square root of 4 times square root of 6. And then simplified it down even more because square root of 4 is 2. So it could be 2 square root of 6. This is the same thing. We're rewriting it as a product of that. Square root of 9, that's a perfect square. So we can now take out, so we've got 3, which is a square root of 9. We can rewrite that square root of -1 and replace it with that lowercase italic I. So that would be 3i. Okay. But also we have to rewrite that as, let me back up. I think I'm getting ahead of myself a little bit. So we could rewrite that as I times square root of 9. And then square root of 9 has 2 possible solutions because square root of 9 could either be -3 times -3 or +3 times +3. So this could be, I'm going to do positive 3i and -3i. Okay, so this shows to the world that you have a square root of a negative number, which is not great. Oh, I did it. Imaginary numbers. I hate them. Oh, I just hate them. They just, there's one part about like math that my brain just doesn't enjoy. All right. We got that out of the way. So let's go ahead. So these next ones, I'm going to do the first one with you, and then I want you to do the next one on your own. So for the first one, we're going to just use the discriminant. So we need to first rewrite it in standard form. So -2x squared minus 4x, and we're going to move that 11 over to the other side. So that would be -2x squared minus 4x minus 11. So your A for this is -2, B is -4, and C is -11. So now we're just going to use that B squared minus 4AC. So that would be -4 squared minus 4 times A, which is -2, C times -11. Okay, so I just put it in that discriminant, this right here, B squared minus 4AC, and that's just all I put that in. So that would be 16, -4 times -2 is +8. 8 times the -11 is -88. 16 minus 88 is -72. So since that is a negative number, that means that, go up here, that is a number less than 0. So that is no solutions. No real solutions. All right, I want you all to do B on your own if you want to pause, or if you want to pause and work on it, or just wait till the end. I'm going to come back and give you the answer. All right, so Mr. Tucker writes a quadratic function on the board. For what values of n will the function have 2 real zeros? Or, and again, sometimes you see x-intercepts called the zeros of a function. That's where like your y value is a 0. So sometimes they're called the zeros because that's where it crosses that x-axis. So what numbers will this have two x-intercepts. So for it to have two x-intercepts, the discriminant has to be a number greater than 0. So if we look at this and think about if this was first thing I'm going to look at and do, because I like a perfect square trinomial, I am going to think about 16, because 16 is, if I were to replace this with 16, did it right on the line there, half of 8 is 4, and then 4 squared is 16. I did a completing the square to make that a perfect square trinomial. I'm going to go ahead and plug that into the discriminant and see what I get. So A equals 1, B equals 8, and C equals 16. All right, so B squared, so 8 squared minus 4 times 1 times 16. All right, 8 squared is 64 minus 4 times 1 is 4. 4 times 16 is 64. So that's going to give me 0. If I had a number less than 16, so I'm going to now look at this being 15. Let me look at 15 for this. So I'm going to put 15 right here. I'm going to erase that and put 15 in. And now I'm going to see what I get. Negative 4 times 1 times 15, that's going to be 60. Whoops, I'm still an eraser. And 64 minus 16, or minus 60 is 4. So that is a number larger than 0 or greater than 0. So that means I have two x-intercepts. So my n value has to be a number less than 16. So a good kind of way to get started with this is to, if you're asked a question like this, make it a perfect square trinomial, complete the square, and go from there. And then if it's asking you for no real solutions, then you know that this has to be a number greater than 16. If it's asking for 0 solutions, it can just be n equals 16. Okay? All right, let's look at number 6. And at any time, you will want to try these on your own, work on them on your own, and pause me, and then see if you get them right. That's awesome. Okay, so for number 6, it says that Raphael uses the discriminant to find the number of solutions to this equation. What's his error? So if I'm looking at this, the B is negative 12, the C is negative 21 if he puts it in standard form, and I see right there, he did not, when he put his value of C in, he didn't rewrite it in standard form first. If he were to rewrite it in standard form, that C value would be negative 21 because you have to move it over to the other side, do the opposite. So did not put in standard form. So let's figure out what the solutions are. Let's correct it. So our A is negative 12, so that is correct. So negative 12 squared minus 4 times our A value, which is 6, C value, which is negative 21. Negative 12 squared is 144. And then, let's see, let me get my calculator. Let's see, 24, whoops, times 21. There we go, 504 plus 504 And that is plus 144. I should be able to do this in my head, equals 648. So in this case, it's not no real solutions. He actually has two solutions. Two real solutions. Come on, Raphael. What's going on here? Silly little mistake. So that's what I'm talking about. Like with signs, it can it's a big mistake if you miss a sign. All right. So Jim throws a ball to his dog. Oh, I was playing ball with my dog earlier. He's given up on me. He's gone to sleep. The ball follows a parabolic path. So parabola kind of goes up and down when he throws the ball. Given by this function where y is the height in feet and x is the horizontal distance that the ball travels. So if he's throwing this ball, okay, so this x, that is the height, and then x is the distance and y is the height. Jim makes his equation equal to 12 to see if the ball will reach a height of 12 feet. Use the discriminant to determine if there are any real solutions to this equation. So let's go ahead and find the discriminant. So we need to put it in standard form first. So that would be negative 5x squared plus 11x plus 4 equals 12. Subtract 12 from both sides. And then we've got negative 5x squared plus 11x minus 8. And I'm going to get rid of my little thing over here so I can write out our A, B, and C. So A equals negative 5, B equals 11, and C equals negative 8. Okay, so for the discriminant, this would be 11 squared minus 4 times negative 5 times negative 8. So 121, and then minus 160. Is that right? So 20 times negative 8 minus 160, yeah. So that equals negative 39. Let me check my work. Yeah, so that is no real solution. So it will not reach a ball of 12 feet. Sorry, John. You're not throwing it high enough. So no real solutions. Nope, sorry. Got to throw it a little harder, buddy. Okay, so we've got our systems of equations again. Use the discriminant to determine the number of solutions to the systems of equations. So with this, we're not going to, well, what you can do is, because I'm here for you, let's go ahead and solve this by putting it in standard form. And then you just put it in your graphing calculator, and you can see on your graphing calculator. Oh, I wish I had my graphing calculator. Actually, I'm going to pull up a Desmos, and it will tell you right there. Okay, so, but we have to get it in standard form first. All right, so, and these are both equal to y, so we can just set them equal to each other. So 2x minus 4 equals negative x squared plus 8x minus 12. So I'm going to move this. I'm going to subtract 2x minus 4 and subtract 2x minus 4. All right, so that's all gone. So now I've got x squared, 8x minus 2x, so plus 6x. And then negative 12 minus 4, that is negative 16. All right, so we've got it in standard form. So let's go ahead and determine the number of solutions by using the discriminant. So let's go ahead and do that first, and then you can graph it. So A equals 1, B equals 6, and C equals negative 16. So this would be 6 squared minus 4 times 1 times negative 16. So let's see, 36 plus 64. 36 plus 64, is that right? Let me work it out. Yeah, 36 plus 64, that's 100. So that is a number greater than 0, so it should have two solutions. So I'm going to go ahead, pull up my Desmos graphing calculator. Graphing. And I am going to put this in and see if I'm right. So this was x squared plus 6x minus 16. X squared, what was it again? Plus 6x minus 16. Plus 6x minus 16. All right, yes, it does have two solutions, and it's two solutions if you got the same on yours as mine are at 2 and negative 8. Negative 8. So it would go right here at 2 and then right here at negative 8. If we wanted to, we can put it in vertex form, and that would tell us the minimum of this value. This is one of those occasions where, because when we did vertex form, we didn't really have one that had a negative a value. But if you look, oh, and I didn't put the negative right there. That has a negative a value. Negative. Oh. And that completely changed it. Yep, sure did. Sorry, guys. See, this is where, and I messed up my own thing. I forgot a sign. I forgot that A is negative 1. Sorry, my B. A is negative 1. So that actually changes everything. So sorry. See, I'm showing, I did that on purpose. I'm showing you how not having a negative sign will completely change things. I guess I need to drink more coffee. So let me redo this. Okay. So 6 squared is 36. And negative 4 times negative 1 is positive 4. Positive 4 times negative 16 is negative 64. 36 minus 64, that is a 5, negative 28. So negative 28. So that is a number less than 0. So that means there's no real solutions and no x-intercepts. So if we were to graph this, no real solutions. What? This is still not coming out right. I'm doing something wrong. What am I doing wrong here, guys? Come on, one of you all. This is when I wish I was in class. What did I do wrong? 6x negative x squared. So subtract 2x. Oh, I see. I see it right away. Hopefully you all, somebody out there found it and is like screaming at me from your computer. That should be minus 2x and that should be plus 4. So negative 12 plus 4, that is negative 8. I'm so sorry, guys.